The record button to the bottom.
Okay. Can you see if it's recording? Have we started recording?
Yes, it just began recording.
Okay, great. All right, so here we are. So we're saying, okay, so I'm working multiple screens here, or attempting to. Yes. So we're saying that in a way we are an informed audience because we understand a bit about presentation. However, I think the reason that the reason that some people are going to fall into that kind of X category of audience member and not necessarily particularly like the way he went about delivering that content is because the context is important. And what he did in that presentation was he showed us what to do rather than telling us what to do. He showed us, he demonstrated it. And in demonstrating it, you know, that was the context. So I think that actually what we need to be as an audience member is told the context of the presentation so we know how to read it. Therefore, we're less likely to be an X type of audience member who doesn't really appreciate what it is he's doing. So we have to be informed in two ways. One, we have to have come across the information already. That makes us informed. And two, I think we need to be given some context as to how to read the presentation. And those two things are therefore content and structure. I wonder if at this point you guys agree with me that there was something about the context of that presentation that made viewing it slightly uneasy. We had to take a moment to get you know, to go along with what he was doing. Do we agree or disagree with that question?
I can agree with that.
Yeah? Okay.
I draw.
Hi, Shanice. Okay. All right, good. So we need information, we need to have some prior information, and we need context, and those two things can really help us. Now, I want us to look at another presentation. And this is a presentation about quantum strangeness. Now, I know that there are some math and I think physics students among us, so you may have come across this before, but I think for many people, myself included, I don't know too much about it. So I wanted to find another informational video and contrast it, another technical presentation, and contrast it. And what I want us to do is watch the first 5 minutes and 37 seconds. And so I'm going to stop this tab and open a new tab, and we'll share it and watch it together. So we're back here. Let me come back to my YouTubes. No, not that one. Okay, so I'm going to share another screen with you, and we're going to watch this YouTube, this TED Talk together. And this is about quantum strangeness. We're just going to watch 5 minutes of this one, right? I want you to come along with me, and we'll see what we think of this. Aaliyah, did you stop hearing because I muted?
Most likely.
Oh,
because
sorry.
we didn't hear probably about the last minute.
The last minute. Oh, okay. Let's go back to here then. That's fine. Okay, so we're going to stop that one there. Let me come back to my slides, if I can. Come back to my slides. All right, so we just watched 5 minutes or so of that video. Right, so here's my question to you now. That was a technical presentation, as was the first one. What do you understand about quantum strangeness? Who got it? Who got it? I'm sure there are some smart people out there that have either come across this before or, you know, took on board what she was saying because you have a mind for these scientific principles. Anyone want?
Why are we still calling it strangeness, though?
I think that's the term that the scientists use. They call it quantum strangeness. I got that from her.
Oh, okay, because I was following what she said and I loved it.
Yeah. Oh, yeah. Okay, great. It was one of the, I think quantum strangeness is just one of the kind of 3 key principles for quantum theory. So what did you get from it, Dwight? What do you understand about quantum strangeness then?
Okay, well, first of all, it's a step up from regular what's it called, coding.
Okay.
So what they did is that they removed binary coding. So zeros and ones no longer exist in this this next gen version of how a quantum computer would actually calculate probability. So it removes I should say it minimizes 0 and 1 out of the equation. So whatever somebody chooses to do, it can either do the opposite or it will change the outcome. I find that really fascinating.
Right. Okay. All right. I decided to look at the comments that followed her video to see what people understood about what she said. And here are some of the comments. They said, so basically the quantum computer waits until the user plays and just always plays the outcome where the computer wins. That sounds like Vegas. They're making some point there. Somebody also said the quantum computer never looks at the coin before the flip, and you never said whether you flipped it or not. The quantum coin is put through a quantum gate. If the coin is tails, flip it, otherwise it's heads, so do not flip it, etc., etc. So how confident are you that these comments are correct? Dwight, since you answered, is that correct?
Now looking at the comments, I just know.
Yeah.
I can't answer off the top of my head right now after taking that comment a little bit.
Okay, okay. I think you're sidestepping the question a bit. Because I think if we, okay, I'm not saying you don't understand it, but I'm saying these commentators of the video had this perspective, and I think if we were sure that they are correct, we could say we're 100% confident that these comments are correct, right? You'd agree with that statement at least.
Yeah, yes,
okay.
I do.
All right. So let me ask you this, and then we'll come back to some more comments. For those of us who weren't so sure, and maybe including Dwight, if we're not 100% confident that those comments are correct, if we're not 100% sure that that information is correct, why does this talk not work for us? Or who better would it work for? Because there were some disputes in the comments, and I'll show you those in a moment, where people said actually those comments weren't correct. That isn't the correct explanation.
Can it be for a particular audience? Like, hey, it's Anna talking. Can it be for a particular audience who who are in that specific scientific field? Is that the question that you're asking? Like, why some persons will not have understood the message she was sending?
Yes, possibly. So if we go back to the the requirements of a technical presentation, it is that it contains information, that it is persuasive, and we have this question mark as to whether or not the audience needs to be informed in various ways, either informed because they're aware of that content, they've come across it before, or informed because they're given some context as to how to read the presentation. So I would agree with you that someone who is better informed about the information would be someone who would appreciate that talk and be very sure of whether those comments in the commentary afterwards were correct or not correct. So I would agree with that, yes. So it's a complicated idea and maybe we need more information. What did you think of this coin metaphor? Was it good or bad? I mean, for those who felt confident that they got the information. Sorry, Dwight, I'm picking on you a bit because you're the only one who said something. Was the coin a good metaphor?
Yeah, I don't see why not.
Okay. All right. So you say it was a good metaphor.
Yeah.
Anyone not like that coin metaphor? Did it help you or not? Anna Marie, did it help you?
I actually felt that it helped me a little bit actually. It kind of because well, from my point of view, I'm not really familiar with the topic.
Yeah.
So when she spoke about some things that sounded familiar in other what can I say, in other like forms of academia or like in other discussions like the Bitcoin, and then she's talking about the 0 and the 1 being binary or not binary, like those kind of terms I've heard thrown around in other discourses. So I was able to better understand the material coming from that lens instead of the purely scientific lens, which I'm not familiar with. So
Okay.
I think it was helpful.
You think it was helpful? Okay, good. Now I was working from another screen to read my notes and it's jammed. So I'm gonna just refer to my notes here and reveal some of the things that I was asking. Okay, so here's my question. If we liked so we heard the metaphor of the coin, either the metaphor of the coin was bad or good in our estimation, or her use of the metaphor was not so good, or it was perfect, according to whether we understood the information or not. And according to the comments that followed, some people were saying things, and it turns out that those things perhaps weren't completely correct. All right, I am going to make a point here, and I think I'm going to help you understand the point when we watch this third video. And this is our last one on quantum, and then I'm going to spend a couple of minutes finishing off this part and get on to the motivational presentation. All right, so we have some ideas about what is required in a technical presentation. One of them is about being informed, and maybe being informed by being given some context. And as we're saying, maybe being informed because we already have some information. Okay, so we're going to watch 3 minutes of this video. I'm going to put it up and have you watch it with me. Let's see if I can get to it. No, it's not that one. Okay, here we go. Oh, no, sorry. All right, so we're just going to watch 3 minutes of this video. And this is another person explaining this quantum strangeness.
Computers. There's a lot of stuff out on the internet and on YouTube explaining quantum computers, but frankly, they're all pretty advanced and pretty confusing. So I'm going to try and boil it down in an easy to understand way. Okay, so we all know that normal computers uses bits, zeros and ones for data and processing. So for example, if I have 4 bits in a row, I can represent a bunch of numbers. For example, 0000, 0001, 0010, and so forth. And I can keep on going. Now, quantum bits are also 0 or 1, but it can also be 0 and 1 at the same time. Does that seem really strange and confusing? Well, it's not. It's actually pretty easy to understand. For example, let's say that a bit is kind of like this coin. It can either be heads or tails, just like 0 or 1. It can only be either heads or tails, right? Wrong, okay? If I were to toss this coin, you can see that while it's in the air, what is it right now? Is it heads or tails? Now, in a weird way, it's heads and tails at the same time. It doesn't really even make sense until it collapses in my hand and I observe the coin, and then I can see what it is. So that's the idea behind a quantum bit. It can be a 0 and a 1 at the same time. Okay, great, but what does this have to do with computers? Well, now is where the fun begins. Let's go back to those 4 bits. Let's say that I am trying to crack a password. The password I'm trying to crack is one of these numbers, but I don't know which one. So I've devised a machine to try them all. This is a normal computer. I take one number, I put it in my machine. If it's wrong, it gives me an X. But if it's right, if the password is right, then yay, I've got the right number. So a normal computer would try each and every one of these individually until it finds the right answer. Now, what if we use a quantum computer? So instead of putting in these 4 regular bits, we put in 4 quantum bits. Now remember, each bit is both a 0 and a 1. That means these quantum bits are all the numbers all at the same time. So when I put the quantum bits into my machine to find the right password, what comes out the other end? Well, it turns out the machine is saying that I'm both right and wrong because I gave it both right and wrong answers at the same time. I still want to know what the correct password is. Well, there's a technique called a Grover operator. Okay, this is actually a real thing where you can sweep away all the wrong answers and what you're left behind with is the right answer. Okay, so that's the beauty of quantum computing. Instead of...
Okay, so we're going to stop that there. All right, and come back to my slides. All right. So what do we understand about quantum strangeness now? Or why is this a more satisfying explanation? Not Dwight, because he understood it perfectly the first time. Jordan, I see you have your mic off. You have a comment for us? Jordan? No, am I reading that right? Okay, somebody else. Okay, all right, no.
Dr. Shepherd?
Yes.
Dr. Shepherd, can
yes.
I know I may be steering a little way away from exactly what is quantum strangeness, but can I just put in my 2 bits on this? My 2 bits went this way. The information that was hollowed out from the first presentation, all the format that you mentioned, strangely enough, the second presenter filled us with a lot of information, but she did not give us any of the niceness, the high pitches and then the low tones and the body movements and so forth. But then this final presenter, he gave us, he informed us of what we didn't know. He gave us information that we could work with so that we could follow along with him. He was very persuasive. He had his voice, his tonal values went up and down and so forth. He was very, very persuasive. I wanted to hear him. That second presenter actually toned me out. She was just flat.
Okay.
And the information of itself became cohesive. All of it kind of came up with the final presenter in that we had a lot of numbers, we had the images, we had his tonal values and so forth. And I see this as, I'm sorry, I see this as having come to a finalizing of the entire understanding of how to do this proper presentation based on everything coming together in the final presenter.
Right.
That's my version of things.
Right. Very good. I think that's a really good explanation of what's happened. Let's just see what some of the commentators said, some comments that came after. So this is the second, sorry, this is the presenter we've just heard. These were some of the comments. This is the best explanation I've seen these days. Sorry, I'm just admitting a few people. Searching a starting point for quantum computing understanding. Someone else said the Grover operator he's talking about is not a fundamental feature of quantum computers. It's really only pertinent to the so-called Grover algorithm. Nonetheless, the commentators, the people who commented, were generally more satisfied than the people who commented on the Shahini talk. And so, why did I put this slide up? Oh, I was wondering, what was the expectation of the first speaker? What's the expectation of a TED Talk audience?
Not to inform us.
I think we do want to be informed. I think from all the TED Talks that we've come across so far, we actually want to be able to see things in a new way. I would say that we expect innovation from a TED Talk. That's my perception of the TED Talks. I'm wondering what yours is.
Sorry, go ahead.
I think TED Talks really aim to show the perspective of the speaker, mostly.
Yes.
What their ideas.
I think from what we know of TED Talks, I would agree with you completely. We get the speaker's perspective, and often it's a new way of seeing something. It's a unique way of seeing something. And we're also expecting a vision of the future. And if you listen to the rest of her talk, she does do that very well. My inference from the comments that came after her speech is that she did something a little bit wrong in delivering that information, which is why, in part, we understand this idea of quantum strangeness much better having heard the second talk on quantum alongside her talk on quantum. That's my perception. So I'm going to have to look at my notes here. So we expect to be entertained, we expect to be given a vision of the future. However, I think we are more informed about quantum strangeness when we saw the second talk on quantum, and therefore we now become an informed audience. We heard her definition of the coin example, and she actually did something that I think was a little bit problematic. Let's look at some comments that came after her talk. One person said, "The coin flipping thing told me absolutely nothing about how quantum computers work." And someone else disagrees and said she wasn't supposed to be speaking about the circuits of computers, and it is how they work. The superposition is the only concept that people don't understand. So it seems from the comments that people actually misunderstood or had varying expectations of what they were going to get from the talk. And also, we had these comments here, and these are from people, I guess, who understand quantum computing quite well. This first one at the top from Peabody Wormsworth is actually a comment about somebody else's comment, and he says that that other person's explanation wasn't right and that there are better explanations, and he refers to some kind of scientific or some block sphere, some place to get information, or this is what is block sphere? It must be a concept, he's saying. So he's talking about the concept of gates, and somebody else said that her use of the metaphor was wrong. And actually I read over this a few times. I had the benefit of being able to read it like 4 or 5 times to get what he's saying. And actually I really do believe this. What she did was she took the idea of quantum strangeness, this idea of the coin flip, which is what the other presenter did, the other speaker did. So they used the same thing, but she put it in the context of a Vegas game. If you flipped a coin, and how you would feel. And so what she did was she conflated the idea of the human calculation of risk, how comfortable we are and what our expectations are of flipping a coin, with quantum strangeness. And those two things did not work together. So I actually think she told a bad story. She used the metaphor in a bad way. According to the comments that came after, there is disagreement, misunderstanding of what the talk was about and what she actually said and how it really works. So let me just finalize on this then, finalize what I'm saying. So I'm saying these are the two things. This was my hypothesis at the beginning, that you had these 2 steps that you need to think about, and these are the 2 things that you need. If you have a good technical presentation, you need to define your audience expectation early on. And I think there are a couple of ways of doing that. You focus in on the idea and you give an idea of what structure it is you're using. So you really do help us with context. And secondly, you need to be conceptually clean. Those are my words. There are lots of different ways of saying it, but you cover the idea simply and that you build the knowledge sequentially. And I think she didn't use a clean concept by using this metaphor of the the metaphor of the coin, but in the Vegas context and how we would feel about flipping a coin. It just kind of muddled things. Whereas the other presenter used the same coin metaphor, but he explained it much more cleanly, I would say. How do we feel about that explanation for a technical presentation? Those two things. Agree or disagree?
You're totally right.
Okay. All right.
Which proves your hypothesis was correct in the first place. So the independent variable does control that dependent variable.
Right. Thank you. Okay. Dwight is championing my idea and I didn't even have to press the point. So thank you. All right. So very good. Now I have a couple of things I want us to look at together. Can I go for another 10 minutes or so? You know what? We have 5 minutes left on this link. All right, so let's have a quick look at this. The motivational speech, by contrast, what do you think makes it different from the technical presentation? The motivational speech. And I'm kind of giving it away here on this slide. How would you define it? If you've ever heard a motivational speech, how is it that it's working for you?
Ignite something in the audience. So you want your audience to leave with a sentiment or like with a conviction that, you know, whatever it is that they're facing or whatever the topic surrounds, that, you know, they could maybe if it's something they want to overcome something, maybe they could overcome it, or they could improve themselves, or you just want them leaving with that, you know, temporary as it may be, but leaving with that feeling that they could achieve something.
Yes, yes, I would agree with you. So I was thinking about a good way to explain why motivational speeches work. And I personally really like them. I mean, I think one has to be in the right mood for them, because sometimes if you aren't in sync with the information that's being given to you, you feel like, okay, well, these are great ideas, this is a great vision, but my life isn't there. You know, when people say, you know, just keep pushing on, go for it, you know, don't worry about any obstacles. You think, yeah, but the obstacles have stopped me from doing X or Y. So anyway, I think the main contrast is the technical presentation is about giving you knowledge, and the motivational speech is about taking you on an emotional journey. I think that you could do both of those things in a technical presentation. You could kind of be quite emotive and cause people to emote along with you and feel. But I think the motivational speech, it's really foregrounds this idea, and it's, you know, kind of abstract in the way that it's trying to convey these ideas like hope and opportunity and love, and concepts like that, which aren't necessarily as not necessarily as tangible. We can't put our finger on them in exactly the same way. And there is a video that I'd like us to watch, but I'm going to let you watch that in tutorial. And I'm going to send the link, I'm going to put the link on the Google Doc for my fellow tutors to watch. These are my ideas, that the motivational speech, and I'm going to end on this slide, the motivational speech sets up a binary. And so it sets up, you know, two options. Newspaper journalism does the same thing. It often gives us a pro and a con. That the message is simple, and actually we can be less informed when it comes to a motivational speech, in the sense that the core of the message is the emotional journey, and presumably all of us have experienced these emotions or feelings. We all have things that we can relate to when hearing those motivational speeches. Unlike a knowledge-based speech, an information-based speech, a technical presentation, where you need some kind of information to follow along. And I also think the language of a motivational speech is visionary, often by relying on in literatures and linguistics, we talk about semantic depth. When you use a metaphor, when you use big ideas for explaining quite abstract concepts, you try and get deep without actually having to pin down all of the specific ideas. All right, so we're going to run out of time on this link. I'm going to share the YouTube link with the motivational speech on the Google Doc for tutors, so you can watch this in tutorial. And I'm going to let us work through an example in tutorial of creating a technical presentation and creating and contrasting that with a motivational speech by using things that are kind of counterintuitive as topic ideas. And I'm going to leave it there because our link is about to end. I want to thank you very much and hope you enjoy your tutorials. I'm going to do mine on my Blackboard Collaborate link. So students from my group, please find me there in a moment. All right, thank you so much.
Thank you, sir. Bye.
You're welcome. See you.